how many ways, okay, can we arrange, the eight children, okay, okay, if the two oldest, okay, are always next to each other, Okay. Now we're just going to make a little assumption here that every single child is a different age to every other child, in which case we can always find the two oldest children. Okay, so just to make that particular assumption. Okay, but let's think about this here now for a moment. Yeah, the two oldest kids need to be next to each other. Okay, so we're going to have the two oldest here. Okay, the two oldest, okay, they need to be next to each other, them two kids, yeah, okay, and all the other kids, okay, can be arranged all around them, if that makes sense, okay. So actually, technically, to keep these two kids together, what we're going to do is we're going to consider them as one. Okay, we just consider them as one child, yeah, or one person, yeah. Let's do that. So instead of us having, so if they were the two oldest, yeah, well then we have 6 remaining, yeah. If you think about it, we have 6 other kids that could be anywhere, okay, around these particular two, okay. So there's 6 remaining. So we have in total now we have 7 objects, okay. So there's 7 objects, okay, to arrange. Okay. Now it just happens that one of the objects represents 2 people, but if that object is going to once again get arranged within these 7 objects. So I want to now arrange all these 7 objects. I had got 8. Okay, there's my 6 and my 2 oldest, but I keep my 2 oldest together, which makes them 1, so now I've got 7 in total. So the total number of ways that we could arrange these is 7 factorial, okay? And have we calculated 7 factorial? I think we did. I think it's 5040. 7 factorial gives us 5040 ways, okay? Now that's 5040 ways to arrange 7 objects. But let's just keep in mind that these two here, these 2 oldest, okay, the 2 oldest, okay, the oldest, let's say the first oldest and the second oldest, okay, could be arranged in, well, they could be arranged in different ways. The second could be here and the first oldest here. So there's actually, because there's 2 of them, those 2 people could be arranged together side by side 2 factorial ways, okay, if that makes sense, okay. So actually these 2 can be arranged 2 factorial ways, okay. So of the 7 factorial ways that we could arrange the 7 objects, okay, well, there's 2 factorial ways to arrange these 2, okay, which actually is just equal to 2. So in total, we'll have 5040 times 2, which gives us a value of 2 times 5040, which gives us, well, that's going to be 10,080, okay, if that makes sense, yeah. Okay. Another way to sort of consider this particular question here, maybe if I just do it out again, okay, is that we have, if you think about it, sorry, excuse me, is that we have a certain number of objects, okay, we have a certain number of objects, we want to find out how many ways they can be arranged, yeah, okay, we have a certain number of objects. Let me actually move this here, okay, so once again, let's just consider the example again. The example, there's 8 children, okay, sitting on a bench, okay, okay. In how many ways can they be arranged, okay, if the two oldest, okay, are always next to each other, if that makes sense. If the 2 oldest are always next to each other, okay. I've actually just done that, haven't I? Yeah. So we've actually just done that particular question here. Okay. So let me just write it out again. The 2 oldest are always next to each other. Okay. Well, I've actually wanted to do it a different way. Yeah. Okay. If we actually consider it as based off counting rule 2. Okay. of counting rule number 2. Okay, counting rule number 2 is if there are k1 events on the first trial, k2 events on the second trial, and kn events on the nth trial, then the number of possible outcomes is equal to k1 times k2 times kn. Yeah, all the way through to kn. I suppose the question is can I re-represent this in that particular fashion? And actually, I suppose the answer to that particular question is actually no. I don't know why I sort of really got ahead of myself there. Okay, but anyway, let's have a look at another example. Okay, because I've already done this one here. We consider the two people that need to be together. Let me just rerun that here. There's 8. There's 8 people. Okay, 1, 2, 3, 4, 5, 6, 7. There's 8 of them. Okay, the oldest and the second oldest, okay, need to stay together. Okay, so in total, what we have is we rearrange these total number of objects. So we have there's 7 objects. Okay, that needs to get arranged. Okay, which is 7 factorial. Okay, but let's don't forget that the two objects, which are the oldest children, okay, the oldest and the second oldest, can be arranged in 2 different ways. They can be arranged in 2 factorial ways. So for each one of these 7 factorial arrangements, okay, there's also 2 factorial arrangements of these guys here. So that gives us 7 factorial.